Boom. Okay. All right. We're in there. And I am just doing some odds and ends here just to make sure everything is in proper working order for anybody that I'm trying to reach. there's always a little bit of extra going on here and there, folks. So don't mind me as I get through this. But yes, hi, it is me once again, Brian Sapinski. Welcome once again to our live streams here. I'm back here on Tuesday, March 31st, 2020, as promised. So we are ready to roll, hopefully, with another with some more assistance that any of you guys need out there with things. So if you give me just one sec, we'll be able to get this started in just a moment. Ba-dum-bum-bum. Okay, good. That should work. All right, so that's right there. Okay, for those of you who who are here for the first time and seeing this, welcome by all means. Please join us. If you have any questions in relation to any of the math work, distance learning that you or your kids are doing, wherever the case is, this we'll answer your questions live here and in person. There's a live chat either to your right side or underneath the window or whatever. All right. I'll put the information back up here. I'll have to clean this up later. Okay. So either submit the questions in the live chat or you could send them to my email. I have my phone beside me to show if there's a if I get a notification. It's you know, it is. I'm so used to like writing in block capital letters anytime I'm doing stuff or whatever. So it's like doing it in the lowercase is a little bit odd for me and stuff like that, especially when it comes to certain lowercase letters that can look like other things or whatever. But be that as it may. So, but there it is, brian.sapinski@gmail.com, or submit topics in the live chat. And even if you don't have a topic, come by and say hi somewhere within the banter. We might be able to invent something, or whatever the case is. So that's the story there. Okay, so all right, so we got some business we got to take care of here with a few different items, and I'll tell you what, just to sort of break the ice a little bit here, and this might be dangerous on my part because I know how Joey can get when he gets involved here. Because once he's here, there's no turning back, and heck knows what it is that he wants here. Let me see if he's downstairs. We'll get something started. But if if you want me to avoid such catastrophe, go take a look. Go give me a topic here in the live chat here. Yeah. Just making sure. Okay, so there it is there. Well, here, I'll tell you what. I'll see if I can avoid the danger with Joey for a little bit. I'll keep what I was planning on the side or whatever the case is. But I do have to summon Brianna because I'm sure that she's got something that she wants to go through and stuff like that that I think she forgot that we're actually on. So what? Brianna? Oh, you're in there? Hurry up here. I started. Okay. All right. Well, I'll tell you what. I know one topic that Brianna was definitely working on, and we'll try and think. Have we done? Okay. We have a suggestion with order of operations. Hello, thank you. Welcome aboard. Yeah, welcome aboard for you. Okay. All right. Now, order of operations. Okay. Now, I'll say this right off the get-go with regards to this. I know that whether it be for you or your kids or whoever this is for, I'm sure that over the years, there's been something that they've been continuously learning to try to go through this concept, however. And I'm going to mention it here, but I'm going to change your way of thinking on it, because there is a very common mistake that's involved with this, and I have to explain it to people many times over. The idea of this whole PEMDAS thing that's introduced to kids in doing the order of operation concept. The word is there, as you know, because of the fact that it's trying to tell you exactly what things are supposed to come before what things. You have the parentheses, you have the exponents. Okay, I'm just sort of putting that there and stuff like that. And then you have multiplications and divisions, and you have additions and subtractions. You have those different things. But here's my argument why I personally do not like using the PEMDAS word. I use a slight variation on it. Okay, and now that Brianne is here, she is aware of this, and she's heard me do this before. Okay, she's heard me use.
You said this in a previous live stream. I think it's the first or second one.
Okay, well, either way, hey, I don't mind. I don't mind repeating.
But
hey, anybody, people come by when they come by. Okay, but I prefer to use this word simply, Pima, and here's the reason why. Okay, let me just give an example of a statement where one of these two,
guys,
one of the problems.
Guys were recording.
Yes.
Because I am just. All right.
Help! He's sitting on me.
Yes. Okay. As he is wont to do.
I just want to watch.
Anyway, okay. All right. Well.
Then watch from.
Okay. All right. Well, here. Try to get another chair, Joe, because I need Brianna's freedom of movement. Okay. Okay. All right. Don't start. Don't start. Okay.
Help.
So here's the problem.
Ow! 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 My leg! Ow.
I've seen many times where people have statements like these. Okay, and when they read the PEMDAS, okay, there's the common misconception is they literally go through each individual letter,
and they say, I have to do the multiplication first and then the division.
Right, exactly.
But
and
technically, division is the same thing as multiplication, but since it's a word, they have to put one letter before / after the other. So then that's what gets people.
Yeah.
So the reason Pima is kind of better because the M is all forms of multiplication and division is a form of multiplication, and then all forms of addition, which
includes subtraction.
Yeah.
Right. Yeah. So these two things, yes. So the M and the D and the A and the S are actually lumped together. I removed the D and the S again, as Brianna said, just to remove that fallacy of thinking that one of those two operations must come before the other, because as we said, division is multiplication, and we did this on a couple of other occasions within certain other topics, that you have to recognize that being that these are the same operation, they're just going in reverse order, they have the potential to be turned into each other at the same time.
Does that mean for this problem we just go left to right?
Right, in this sense, yeah. So, we'll show it the way it reads right now, and then I'll show the alternative just so you have the idea as to exactly how it's what we're saying about them being the same operation is true. So you do the 12 divided by 2, you get the 6, and then doing the 6 times the 3, you get the 18. So that's the result that you should get.
Since we have a mirror image, it looks like 81.
Yes, I understand.
Because it mirrors it instead of what
they know that. They know that for the most part.
So then for us, it looks like 81.
I got that. Okay.
On the screen.
I'm talking. Anyway, now, just to prove that this is the way it's supposed to come out and things like that. Another way you can look at, just to prove that this is the same operation. We've talked about it before in other problems that we were doing in earlier live streams where we talked about divisions involving fractions. We've mentioned before in the past that if you're dividing by a fraction, it's the same thing as multiplying by the reciprocal or turnover of that fraction. So these two operations would represent the exact same thing. Okay, the same type of thing would happen in a problem like this, where you have division of 2. That could be rewritten as, recognizing that this is 2 over 1. If you turn this over, that's the same as multiplying by 1/2. And now when you read it, you see that it's a full string of multiplications. The whole thing strictly moves from left to right, the same way that it would move from left to right in this argument. Okay, so everything that happens here would be the same as what happens here. Okay, so you would have 12 times 1/2, which, again, to re-reference something that I talked about last week, when you're doing a whole number times a fraction, my personal recommendation is divide down first. So do 12 divided by 2 and get 6. And then 6 times the 1 up on top would give you 6 anyway. And then 6 times 3 would give you the 18. And you're all set to go. I know you like doing the multiplication on top first. Again, the only reason why I recommend doing the division on the bottom. Well, I know it's instinctive, and there's nothing wrong with being instinctive. Like I said, don't get me confused here. The only reason why I personally recommend changing that habit, doing the division first, like I said in the previous live streams, is the idea that you want to be able, when you get to the multiplication part, or even the division part, the smaller the numbers you have to calculate, the easier you make it on yourself. That's why I recommend doing the division first, because you get smaller numbers out of that calculation, which makes the follow-up simpler to do. So that's the reason why I recommend that. Okay, but you see there how we change division to multiplication and show that it's the same operation, proving that it doesn't matter which one of these comes first. You just do all forms of multiplication from left to right. The same thing would be true on the addition and subtraction level, and why I don't write the S in the PEMDAS. Okay. So again, here, same three numbers. Okay, but now let me show this. Okay. Again, people are instinctive of doing
this part.
Yeah, again, because they see the A before the S. But again,
it was like
plus 3, right?
If like they were following PEMDAS and like the thing.
Okay, and again, this is incorrect, mind you. Okay, so this is not the correct
result.
result.
7, right?
Yeah, but that's not the correct result.
But what you have to do is first you do like 12 minus 2, which.
And this is what 10, you should get.
And then you get
now
15.
again, just to prove that it's the same operation. Okay, so once again, I could take this -2, okay, or this -2, and I could turn this into an addition where I want to recognize that this 2 on its own, if you took away everything in front of it and behind it, this 2 on its own is a regular everyday +2. If I want to reverse that, if I'm going to reverse the subtraction into an addition, I have to reverse the value of this +2, thus making it a -2 like this. And now, just like before with the multiplications divisions, now you see it's a straight string of additions going straight across the line. So you play those against each other as you need to. So these would combine first. You have 12 positives versus 2 negatives. Which side has more? In this case, the positives have more. And by how much? That's where the subtraction comes in. So there are 10 more. When you do 12 minus 2, there are 10 more positives there. And then 10 positives, 3 more positives, a total of 13 positives. And there's your end result. So that proves how the addition and subtraction are the same operation, just in reverse. Okay, and how the multiplication and division are also reversed. I see it. You don't have to get my attention. I'm looking at the chat.
I'm looking
okay.
2 minutes ice cream.
Okay.
But I drew it in smiley form.
You with that again. Okay.
But I drew it in smiley form.
I got what I got. Okay. All right, so that's the way that works. Okay, now building off of that. Okay, so the question is, especially now with what I just showed here in this specific piece right there. Okay, adding and subtracting signs, numbers, particularly particularly negative numbers. Okay, so the thing that I was just talking about here, when you're doing addition like this that involves where at least one of the numbers is a negative in some way, shape, or form. Okay, what you have to recognize is you have to.
Oh no! Help! Oh no! Wait.
Don't do this to me again.
Okay, so we're still connected to the chat. Someone type in, please.
Okay, wait.
Oh,
Okay, wait. Okay, we're back. Okay.
Just to be sure, someone type in yeet in the chat.
Okay, I don't know what the last thing I said was because there was a brief period of there was a brief. All right, guys, Joey, chill a second. I'm actually gonna need a favor from you, and maybe a little later, Joe, but not just yet. Okay, but do me a favor. Wait. Okay, says I never went. Okay, because it said we had an unstable connection on our end a minute ago. So just bear with me a second. Okay, so all right, as long as we're there. Okay, so I just know that when we look at the rebroadcast later, there might be a skip in what I said. So that's the only the deal there. So that's the only reason we ask that if something happened. Anyway, as I was starting to say, okay, what I was showing here in this part right here with the 12 positives and the 2 negatives. Whenever you're going to add or subtract 2 numbers where there is a negative involved in some way, shape, or form, this is where you have to start comparing the individual values of the 2 numbers. And I sort of think of it like, and I did this in one of, I forget if I did it in one of your videos or if I did one of Joey's videos or whatever the case is. I started talking about this as sort of like gangs against each other in a sense. What I mean by that is this, and again, this references one of the videos that I did with one of them several months ago. There was a show that I used to watch back when I was a kid. This was during the late 80s, early 90s. There was a show I used to watch on PBS every afternoon called Square One TV. It was, and I've talked about it here on the show before here, is that, like I said, it was a half hour every day of, just like, Saturday Night Live kind of sketches, so talking, doing TV parodies, MTV style music videos, game show segments, cartoons, and everything, where they're just demonstrating math concepts. Occasionally, they would have like a brief, like little, like 20-30 second bit in between segments where they would have these little like claymation cones. They would have like blue ones that represented minuses and red and orange ones that represented positives.
And
they would have them face, and they would have them confront each other, kind of like this. So
what, Joey, stop.
Okay, so for example,
okay.
So
guys.
Okay, well, like I said, they look like cones, kind of like this, or whatever the case is.
But like on the live stream, you talked. There was like.
So like this. No, not well. Guys. Yeah, we talked about that too. All right, but now I'm showing it the way.
Blue one.
Okay, all right, wait, chill. Okay, I need this. Okay, just hear me out.
Mr. Dice was erased.
Hear me out. Okay. I saw. So you'd have these. Okay. Yeah, they had their faces on them and stuff like. No, not that. Okay.
What was it? Minus. Plus or minus.
Okay, all right. So like they would have the two gangs confront each other like this or whatever. Okay, and they would show them. Okay.
Like puzzle. Look, it's puzzle.
So they would show that you've got four positives on one side of the confrontation. You've got 6 negatives on the other side of the confrontation. So they would meet against each other, and they would charge at each other in battle, or whatever the case is, with the idea that every positive and negative that came in contact with each other, they would basically dissolve each other and disappear. So these guys would knock each other out. These guys would knock each other out. These two would knock each other out, and then these two would knock each other out like that. Okay, and as a result, you see what it is that you're left with at the same time. It's essentially, like I said, which army has more, the positives or the negatives? And in this case, the negatives win out they went out saying -4, again, using the turnaround that I talked about in the order of operations conversation. It's okay. Don't worry about it. Okay. It would also be the same hello. Okay. It would also be the same as saying this if we flip the signs around. -4 plus -6. The key in this is that, again, it sounds instinctive that that because you're seeing the minus, you're automatically thinking, okay, my mind has to subtract the digits that I see with each other. But you have to recognize that in either of these forms, you've got to recognize that you have nothing but negatives in front of you. Everybody is the same. So as a result, to calculate this, you want to just simply count how many negatives you've got here. And at the moment, how many negative army guys do we have here altogether?
10.
We have 10 of them. We have 10 negatives total. So when they're the same, so when everything is the same sign, you're counting up. That's what you want to see in those circumstances.
Does that mean it's positive 10?
No. Again, when you're adding these things, when they're the same sign, you're simply counting how many of that sign do you have. 4 negatives and 6 negatives make 10 negatives, not 10 positives. You have to retain the sign of what you've got. So that's the story of what's happening there. Okay. Now this whole thing of flipping. Now the last thing I'll just say on this particular thing. So because these are the most common situations. These are a couple. Go ahead.
If you this is supposed to be negative.
Well, okay. Well, we'll understand.
I'd
like to signs numbers just yet. I'm going to probably imagine you're going to see that you're going to definitely start to see it next year in 6th grade to validate that concept. To the person in the chat room, Miss Judith, I don't know what grade level is this for? I'm curious here. If you could just throw me a message there in the chat. I'm just curious what level you're doing with this or whatever. Because like I said, my daughter Brianna's in 5th. And I haven't seen it yet. So I'm wondering if in your case, if it's 6th grade concept, if it's whatever it is. Well, no, wait, that's what we're working with right now.
Oh.
The idea of establishing a number as on its own is either positive or negative. That's what we mean by signed numbers. Okay, that's the whole premise. Okay, so you have those kind of things happening. Now, the one type of problem now in terms of all this changing subtractions to additions, the only type of thing we have not done yet with this is
what?
Okay, you've done it in 4th. Okay, all right. So yeah, I know everybody kind of does it at different levels and stuff like that or whatever. I'll have to check your resource book and see if it's in there, somewhere. Because I would have thought you would have seen it at some point or whatever the case is. So, but anyway, okay. But now I just want to show one other key example in this because there's one other circumstance that we have to look out for, and that's the kind of circumstance where if we have something like this. Okay, so let's suppose that we have a subtraction given to us, and the subtraction reads something like this.
Hard for them.
They took it out of the 4th grade curriculum. We used to use Chicago. There's a new term. I've never heard that one before.
How do you draw
Chicago math? Okay. Well, wait. She parenthesizes Chicago math as everyday math, which okay. I mean, believe me, we're trying to get plenty of things that involve everyday math here and stuff like that. I don't know if you've seen some of our other live streams. You can see some of the higher level everyday math that I've been introducing Brianna to within my discrete math class that I teach on the high school level and stuff like that. We get some of the practicality in there too.
Is Chicago in California?
Illinois. Don't bother. It's a weird, funky shape.
We go. That's Illinois.
Oh, stop it! Stop it! Okay.
Math.
Oh boy.
Here.
She's never even seen Wayne's World yet either.
No, I don't know.
Okay. All right. All
I
right.
forget what it looks like, and I forget how to draw it, but I don't know where it actually is located. But there's Chicago, and then
I'll put.
math.
We'll put the state map back together later, because I know I remember at the beginning of this year you were having a murder of a time trying to get all the states put in place. But here we'll do that later. Okay, all right. Let's get back to let's get back to this. Okay, so here's the thing. You remember before where I've been showing now in a couple of examples. When you have a subtraction, you can rewrite it as an addition. Okay, so I keep the 5 the way it is. I change the subtraction to addition. But as I've been showing the other problems, this has to change also. This says that I am subtracting a negative number right now. I have to change this because of the change from subtraction to addition. So what does this negative 3 become? Again, I have to reverse its value. So I have to turn it into this. And as a result, that's what's there. Okay, you'll hear this is another set of initials that you very commonly hear used and stuff like that. The concept of KCC, you'll hear people say constantly, representing keep, change, change. The idea of that in these to change any subtraction.
If you like,
well, no, okay, all right. You're right. Well, again, that's the multiplication version of KCC. This is the addition version of KCC, and probably this is the more well-known KCC circumstance that
Dad,
you want.
I want you to read this because this is the trick. Good Lord. So this is
somebody wants in.
So this is the trick that we learned in class.
Bigfoot is after us, folks.
This is ridiculous.
What is the?
I don't understand.
What does it say? Puppy what? No, stop. No.
And the trick was, you know what I was getting at, right?
No.
The trick was
This is not a Super Bowl ad. This whole puppy monkey baby thing.
Puppy monkey baby keep change flip because I guess like my teacher wants to make it more fun.
Oh, okay. So they're just trying to come up with something amusing for it. No, I get it.
Remember it. Puppy monkey baby keep change flip.
Okay, sure. Why not? Okay, so but that's in general the way the rule works. Now, depending on what signs everything is before and after the keep change is done, that will again tell you exactly what things need to happen with the digits, and that goes back to what we were talking about before. So in a case like this, you started with a positive number. After the flip, this became positive as well. You're adding 2 positives, and again, 5 positives, 3 more positives, we get 8 positives. If we had something like this, okay.
No, we're doing important math.
If we had something like this on the other hand, then let's say, okay, if you have something like this where now again the keep change. This is a -7 to start. This changes to addition. And this now becomes actually, after you flip it, you don't need the parentheses anymore. That becomes a 4. Now you have 7 negatives versus 4 positives. So now you have to compare which army has more. The negatives have more. Subtract to determine how many more.
3.
So there are 3 more negatives than there are positives. So that would be the end result there. Okay. And here, just to show one where the other side wins, let's say you had something like this. If you had -2 minus, and you were subtracting, let's say 8 negatives. Again, keep the -2, change this, and reverse the value. Again, why do I keep writing the parentheses? I gotta stop doing that. Okay.
It's an instinct.
So yeah, I know it's always there. So
Dang
now
it,
here,
no,
so now you've got
team instinct.
So now you've got 2 negatives versus 8 positives. Again, between the 2, who wins?
The positives.
The positives win. Subtract to determine by 6. Okay, so you end up with that, and that's the way that goes. Okay,
but mommy's team instinct.
Yes, I know. Pokemon Go joke. Okay.
Every day.
Chill.
But it's true.
Chill
You
with
did
that.
play Pokemon Go.
Okay,
every
chill with that.
day.
Chill with that. Let's not get crazy
Hey,
here.
look, it's
So,
a gray Pokeball.
okay, chill.
Yes,
Mm.
yes, it's gray.
Okay.
Pokeball.
All right. Okay.
I'll
I'm
stop,
moving.
I'll
I'm moving on with
Yes,
with or without you.
I'll stop.
Okay. So, all right. So that's the story with the sign numbers. All right. All right. Hopefully that helped you out, Miss Judith, and like I said, don't mind the noise. So that came as a result of it.
Like,
there.
we
Okay.
didn't want Joey like drawing all over the board, so we locked the door, and like Joey's like,
I think they get that.
it's like banging on the door. Like,
okay, we get that. We get Brad.
Let me in!
Okay, we get that. Okay, all right. Okay,
Like, we have to erase this.
all right. Real quick before we go on to the next thing. Okay, while we're on the subject of
I got marker on my shirt.
that stuff here. Well, let's see. You played around too much. Okay.
But
So
it wasn't. It's right here, so it's not on the actual side.
anyway, okay. All right. So while we got
big.
okay, so we got that going there. Again, like I said, hope we helped you out there, Judith.
Yes.
If you got any more questions, please, by all means, throw them out there. We'll take whatever topics we can get here.
And now
okay.
It's time for
okay.
card
Now.
sharks.
No, it's not. No, it's not card sharks thing. No. I'm shuffling this for something we're gonna.
Now it's time
we're gonna
for
do so at the end.
card game.
No, not yet.
Oh.
No, I've got to reshuffle because I was gonna do something with Joey if he can handle it, but since he's not gonna be here, whatever, I've got to reshuffle the cards that I'm using here for your purpose or whatever. But we'll do that in a minute. Okay, here's something. While we're on the subject of again with some other practical maths and stuff like that, I want to show this to you. This is another thing for my discrete guys or whatever. Okay, you remember a couple weeks ago? You remember one of the topics I was showing you where we were talking about voting. You remember? And I was talking.
The weighted voting.
Okay, huh? No, wait.
The weighted voting. Yeah.
That. Well, I was talking about a couple of different kinds of voting.
Yeah,
all right,
like the weighted voting.
Okay, I was talking about a circumstance where I know we did the example with the 4 states around us. We used the electoral votes that they had and stuff like that to indicate like who had more in the electoral college and stuff like that, and determining like what the quotas would be. Sure, absolutely. We're glad to help you out there. Please keep coming by. You and your friends, Miss Judith. Anybody that's got questions, please by all means, tell your friends or whatever. Anybody you think you could use help. We love the company, and we want to be able to help out as many people as we can. So please keep on come by. Hit that subscribe button too.
Yes, please.
Okay, so. All right, so here, Brand. So I was talking to you about this. Now I'm gonna just make a couple of. I'm just gonna make up a few other numbers here. Okay. So all right. So I'm talking about the weighted vote again. So let's say we got 5. So let's say we've got 5 people in a group. Okay, and let's say the person who has the most power in the group. Let's say that their yes vote counts for 10 points. Okay. Let's say that the second person's counts for, let's say, 7. Let's say his goes for 5, and then let's say 4, and let's say 2. So I'm just making those up as a sample example. Okay, now first things first, get me a total number of points that all this is worth, because I want to make sure we have an understanding of what the maximum quota can possibly be for if everybody says yes. Just give me a sum of those numbers real quick.
Everybody said?
Yeah, so how many total voting points would there be in this argument?
There's like a glare, so it's hard to see.
Wait, I got 10, 7, 5, 4, 2.
Like 9.
Okay. That's fine. Yeah. Combine them however you need to. Okay. 9. Well, here, there's a 7 and a 2. That's another 9.
9.
Okay, so you got
7.
Wait. You got a 7 and a 2. That's another 9. Okay, so you got two. So you got 2 9s, which makes 18, and then the 10 is 28. Okay, so there's 28 total points in here. Okay, all right. Now, knowing that there's 28 total points. Now, here's the thing. Now, we talked about this a couple of weeks.
There has to be at least
Well, it has to be
15.
15, right? Because it has to be one notch over 50% of the total quota. So we know that. So we know that. Okay, so we know that 15 is the smallest quota there could possibly be. Now, here's the thing. Right now, there are a lot of different combinations of, as we call them, winning coalitions that could easily meet 15 or above in order to get yes. But that's not the question I want to ask you. Follow this. As you start to raise the quota up, okay? As you start to raise the quota up, what you're going to find is that there gets to be a certain point where starting with the very first person, okay? Starting with Joey's messing with the door, but that's the ring.
No, it went.
Yeah, that was the ring saying the door was open. Never mind. I'll tell you later. Anyway.
Oh.
Yes. Okay. All right. Come back to discussion.
So confused, but whatever.
Okay. Now let me ask you this for 1 second. Take the 10 out of the mix here. When we added just these 4 people, the 7, 5, 4, and 2, how much did we get a second ago? Because we added 10 left. Okay, we got 18. Now here's the thing. These 4 from players 2 through 5, they total 18 votes. Okay, but here's the question: what if the quota in front said 19? If these 4 people say yes and the person with 10 votes says no, will the vote pass? No, it would not. They would fall 1 point short. So what this says, Brianna, is, now follow this. What this says is that as soon as the quota gets to at least 19, this first person has the power, by saying no, to be able to automatically disqualify the vote.
They're
No. That wouldn't. No, it's not. That's not being. That's not being. That's not being. No, that's not being a dictator. But that would represent that now that the first player would have what is called veto power.
What's veto?
Again, like it says, the idea that if they say no, it doesn't matter if everybody else says yes, the vote is disqualified.
Oh,
okay?
That's crazy.
That's the whole idea. Now, as this quota value goes up, okay? As this quota goes up, it will start to grant other people going sequentially down the line the ability to also have veto power as well. The way you determine exactly what the quota has to get to is, again, we established the total of all of these. We established there was 28 total points in these votes. Okay. If you want to see what it would take to give any one person in the group veto power, take their number of votes, subtract it from this total, and then notch the count up by 1.
One person?
So we just determined, for instance, a minute ago, that if we took player 1's 10 votes out, that would mean there are 18 points left. If the quota is 1 higher than that, or 19, that gives player 1 veto power. Now, let's see what it would take to give player 2 veto power. Okay, player 2's got 7. Player 2's got 7 votes. Take 7 off of 28, and that would give you what?
21.
That would give you 21. So if all the other 4 people say yes, that would mean 21. That would mean there would be 21 points total in the vote. But then if you take this up by 1, if you take that up by 1 to 22, that would mean you would need player 2's 7 votes to make a yes. Otherwise, no go. So that means 21 gives player number 2 veto power. If the Q equals 22. So we established that if it was 19, player 1 would have veto power. Okay? Player 2 would earn veto power once the quota hits 22. And by the way, we should say that whenever a particular player gets veto power, anybody that's got as many or more votes than they do also has veto power. So right now, at this moment, both players 1 and 2 have veto. Okay? Now let's see what it would take for player 3 to get veto. Okay? Player 3's got 5 votes. Take 5 off of 28.
23.
Notch it up by 1.
24.
So when the quota hits 24, player 3 gains veto power along with players 1 and 2. Okay?
How is player 2 supposed to get?
Again,
How
Like-
is everyone supposed?
okay, well, wait.
Supposed to get
We're working there. Hold on. We're getting there. We're getting there. Let's go to player 4. Let's see what happens to make player 4 get veto power. Player 4's got 4 votes. Take 4 off of 28.
24, 25.
Notch it up by 1, you get 25. So if the count is up to 25, player 4 gets veto power because without his 4 votes, you can't get to 25. And then let's see what player 5 needs for it to get veto power. And thus, if player 5's got it, everybody can veto with a no. It would mean you need a unanimous or nothing at all. Take the 2 off of 28.
26.
Notch it up by 1.
27.
27. So if the quota is either 27 or the full 28, that means that player 5 also gets veto power. That means if it's up this high, that means you got a unanimous vote of a yes, or if one person says no, it doesn't happen. Okay? But you can see the higher the quota gets, then with the person with the most votes, you could start to say that a no from this person or then these people, so on down the line, negates the whole thing.
Wait, can I just?
So that's the rule of how veto power works. Okay. But then, as you also saw from the beginning, the lowest possible quota that you could have in any of these weighted situations also lends itself to say, oh, there are low ones where no one has veto power, where you could have multiple combinations of people saying yes, where one person does not specifically have to be involved in it. Okay, so that's the story there. Okay, so I know at least I know somebody from my discrete math group was peeking in the chat earlier. I don't know if he is still there, or whatever the case is, but because I know that's what he's working on today. And it's a nice, simple enough concept that you can, like I said, if you've been looking in on some of the past live streams where I've been doing some of my discrete concepts with Brianna, you can see that not all of them that I've shown or that we're going or that you're going to see as we work our way along are necessarily very are not all that complicated in terms of their calculation nature. It's just different kinds of math that you might not be familiar with seeing before. So that's the story of what we're trying to aim for in those in those circumstances.
They all want to say yes, but then he's like no.
Nope, and he's ruining the party for everybody else. Exactly. Yes.
And
yes.
He's just like,
and believe me, we know plenty of politicians that on every level, local, state, federal, that like to do this same kind of thing. Yeah. If I don't get my way, nobody can have theirs. You know.
Is that?
And that's where I'm leaving it. Okay. Because we know we got enough problems happening in this political world as it is. Okay, so that's the story there. Okay, all right. No. I said I'm leaving it there. Don't provide. No. We got enough suggestions as it is. Okay, so don't go crazy. All right. Okay. Now, all right. Now I said I was going to. Okay, I said I was gonna do this. Okay, all right. Let me see if I can pull this off here because I got. Oh,
good Lord! It sounds like
some people are hard. Some people are hard to entertain. It appears. Okay, so. Okay, all right. We don't need. All right, I don't think we need any more examples. Okay, we're good. Chill out. Okay, stop. Okay, all right. Okay. Before we get. Ooh, I like that.
How to change a
decimal into a fraction and percentage. Okay, all right. I like that idea. Okay.
Look, he's breathing fire.
Okay, all right. Here, clear the board for a second.
Good Lord.
All right.
Keep Mr. YouTube at his ice cream. He wants his ice cream.
Oh, crazy there.
It's starting to get a little messy.
All right.
It's starting to get a little messy.
Maybe downstairs, perhaps, but let's see. Okay.
What do you mean?
All right. Decimal into a fraction and a percentage. Okay. I wish I had the song of this memorized. Again, I'm having another Square One TV flashback with this because you remember I was saying earlier in the show today, I was saying how there was how they would occasionally do like MTV style music videos or wherever the case is to do different math concepts. I know definitely that there's one that they did where they talked about, and they did this for a couple of non-music video segments too, where they talked about changing fractions to percentages and stuff like that. But the song definitely did that general concept, because now we've talked about percentages before. We said that if you have a number, for instance, like let's say 6%. Okay.
Should I just erase this? I'm gonna.
Sure, whatever. Okay. If you had a number like let's say 6%, okay, we talked about that when you're dealing with percents, or like I said, if you break the word down, cent being the key, okay, because cents we use to represent what number? Like I said, cents in a dollar. Century means how many years. All those kind of things. Cent. That key word or prefix cent always refers to that one same number. What is that number? We said. Okay. Don't. Okay. Can you not write that big because I need the space? Okay. We got the idea. Don't use that. Yeah. Don't use that.
Yeah. Joey ran out the marker.
Ran out the thin one. I told you that last night. Okay, yeah. The key is always based on 100. So we always want to represent that when we see a percent like that. So you're saying that this represents 6 out of 100. Okay.
I think I have to go. I think.
Yeah. Why don't you go check and see what?
Shouted for one of us.
Okay. Yeah. Why don't you go see? Why don't you go see here? Go here. Go here. Go distract down there, and I'll pick it up from here. Okay, so you got 6 out. I don't know whether that required a Tarzan yell, but sure, why not? Okay, so 6 out of 100 is the basis of that. Okay, so therefore, anytime you have something like this, something out of something, that could be translated into a fraction. So it becomes 6 over 100. Okay. So that's what that gets. Now, I've also said on previous shows here that anytime you have a fraction, that's used to represent the operation of division. Okay, so when you divide 6 by 100, what you're going to see is that every zero that appears here represents taking the number 6, okay, and moving the decimal. For every zero, you got to move it one place to the left. So it creates this decimal as a result, 0.06. Okay, so that's the basis of how it is that ultimately looks or whatever. Okay, but yeah, the idea is that a percentage is saying how many parts do you have out of 100. That's the thing. So same thing. So if you had the number 15, let's say, okay, again, 15% representing. Excuse me 1 second. Sorry. Okay. Anything can happen, friends. That's part of the joy. I am dealing with family life just the same as you are. Anyway, so 15%. Again, that represents 15 out of 100, which would create that fraction as a result. And then once again, the 2 zeros at the bottom mean that you start with the whole number 15 and move it over 2 places to the right, or the left rather, and you create the decimal 0.15. So that's how that plays out. Okay. So all right. So you see how it works in that direction. Now, just to change it up a little bit as we go along. So I started from a percentage, for instance, in this example, all right? Now, if you were dealing with one of the other kinds of numbers, okay, the question, okay, how do you convert to the other forms or whatever, okay? So let's say, for instance, that, all right, let's suppose that you had the decimal to start off with, because I think that was your question, Ms. Judith, to begin with and stuff like that. Okay, so if you have the decimal to begin with, it pretty much works itself in reverse and stuff like that. So if you've got, for example, the decimal 0.24, okay, for every decimal place that you have, every decimal place represents a 0 at the bottom of a fraction. So in this case, since I've got 2 decimal places, that would mean that in the bottom, I would have a 1 followed by, for 2 places, I would have 2 zeros, okay? With that in place, what would then happen is I would then have to write this number without the decimal, just write it as a whole number. So it'd be represented like this, 24 out of 100. And again, since I'm playing off 100, that fits the percent to make a percentage out of it, and you get 24% as a result there, okay? Now, so far now in all of these examples, okay, it's all fine and good that everything has worked out to having 2 zeros on the nose. But what if you're dealing in a situation where the decimal is something shorter or longer? Oh, okay. Hang on, I'll be right with you. What would happen if the decimal was something shorter or longer that required fewer or lesser zeros? How do you get the percentage then? What, you okay? Okay. Everything's changing on a dime, folks. Okay. So what happens if the number you're dealing with has fewer or less decimal places? So like, what if you're doing something like this where I should move the phone downstairs. Okay. So what if you have something that's like this? What if you have just like for hello, blah, blah, blah. Okay. What if you have something like this where it's just a 0.4, a single decimal place? Now follow this. Now, because there's only one decimal place, that means that you're only going to need a 1 followed by 1 0 at the bottom. That creates this fraction, 4 over 10. All right. Oh, and by the way, I just want to make before anybody that's watching this either now or after the fact. Oh boy, what's happening now? What's happening now? Bear with me a second. I'm sorry, folks.
I'm being followed.
Oh, you're just trying to get away. All right. Okay, here, answer this question for me, Brianna, while you're trying to gain your breath here. I've got the fraction 4 over 10 here. I want to make this fraction match the other ones so that it has 100 underneath in order to make it to convert it into a percentage. So here's the question. If I try to turn this 10 to 100 by adding an extra 0 to it, like this, okay, what would the 4 become? What would the 4 have to become in order to keep the value of this fraction the same? Because if this gains a 0, what does the top have to do? So the 4 would become 40. Okay, and as a result, that would mean that this becomes 40%. Okay, so that's how you have to look at that. Now, as I was starting to say a second ago, before chaos ensued.
FBI, open up.
Stop. Anyway.
FBI, open up.
Shh, quiet you. I understand that a number of these fractions, as I posted them here at the moment, can be reduced in some fashion, and that's fine. There's no problems with that. I understand that completely. But for the purpose of just making a conversion, obviously, if any of these fractions can be reduced, absolutely, you can do so. But I would recommend, if you're trying to also get a percentage out of it, my recommendation is save the reduction of the fraction until after you found the percentage. Then you can reduce this to its lowest terms and do whatever it is that you want there. Okay, so there's an example of what would happen if you've got a fraction that if you have a fraction that has fewer than the number of decimal places that you would normally see to make a percentage. But what if it has more? What if you've got a decimal that read like this? Just scratch this up here so you can see it. Okay, so what if you had a decimal that read something like this? What if you had point, let's say, okay, well, let's just go simple. 1, 2, 3. Okay, now, if you're trying to make a fraction out of this, again, the denominator, okay, we make this 123 at the top, no decimal like we had before. Now, again, the bottom needs a 0 for every decimal place you got. This time you got 3 decimal places. Okay, well, okay, no problem. Well, here, stay with this one because you're going to want to see this. Because now you got 3 decimal places. So a 1 followed by 3 decimal places is not 100, Brianna. It's a what? A 1 followed by 3 zeros is what number? A 1 followed by 2 zeros is 100. A 1 followed by 3 zeros is a...
1,000.
Thank you. Okay.
Sorry.
No? Oh, relax. It's fine. I know. And I know. You're trying to get your head back because of everything happening downstairs. Anyway, okay. But now, here's the problem, though. As far as making a percentage out of this, okay, this does not fit the 100 that we had before. This time, to make it match for percentage purposes, now instead of gaining a 0, this has to lose a 0. So here's the thing. This 0 is going to go away, but I can't keep, if I do that, I can't keep the 123 reading as it does. What's gonna happen to this? There's no quote unquote 0 to lose here. So what do I have to do with the 123 to make it lose a 0? Where's this decimal point going to go? Since I lose a place here, I have to lose a place up there. So what direction do I move the decimal point to lose a place? I move it to the left, and that puts it right here at 12.3. And right there, then, once again, your percentage is spelled out directly for you right there. So now it says 12.3 parts out of 100, and therefore you have your percentage of 12.3%. So the whole key is that hopefully if you have a decimal that has exactly 2 places, you can make the percent transition immediately just like that. Okay? Right? Well, that's the whole idea. If you have any decimal that's either longer or shorter than 2 places, then you have to either add or eliminate the number of positions necessary in order to line it up with the 100 so you can see exactly what it is that's supposed to be, because a percentage always has to be based around the number 100. So here, I'll do one more real quick just along the longer lines here. Let's take an even longer one, for instance. So follow this, Brian. What if we had this one? Let's say we had 0.2468. Okay? So once again, write it without it, 2468. Okay, now again, there are how many decimal places? 4 decimal places, so we need 4 zeros at the bottom. So we've got this out of 10,000. But again, to write the percentage properly, we only need 100 here. So once again, 2 zeros gone to make it 100. But if I eliminate 2 places here, 2 places have to go away here. So 1, 2, the decimal point ends up right there. And there's your percentage right there, 24.68%. So that's the way that would check. So if you have to take a shorter decimal and add a 0 to make it longer, go ahead and do that. If you've got more than 2 decimal places, strike out and move it back to the left so you can see it that way. Okay? And of course, yeah, you move the decimal either forward or backward, right, depending on exactly what positions that what position that you need it in and stuff like that. Okay, the whole idea is to make it line up to the 100. Okay, now and that's always going to be important from when you're looking from fraction to percentage conversion and stuff like that or whatever. And now I'm using the fraction as the intermediary here for this conversation. Ultimately, what you'll also see as you work your way along is that if you compare the raw decimal to the percentage, you'll notice that the digits stay exactly the same, but you'll notice then that the decimal point is positioned two places different between the two. Okay, because if you're going from decimal or from decimal to percentage, you'll notice that the decimal has effectively by the ends moved over two places to the right of where it's starting the decimal to make the percentage that way. If you're going the other way around, if you're going from percent to decimal like this one, okay, it ends up going two to the left. But again, that's a result of doing the division, by 100. So if you can see the two position move over forward and backward without using the fraction as the intermediary, that helps you, all the more. But at worst comes to worst, if you got to use the fraction as the intermediary and get it lined up where you could see the hundreds, so you can see exactly what value it's supposed to retain, then use that too, and it's just as good. And yes, I thank you absolutely. I appreciate that I was able to help explain that to you. I thank you for the compliment. All right. So see, we're here to help. That's how it all is now. Okay. So all right. Okay, we got a couple of minutes left here, at least for the moment. Unless you got something else, by all means, I'll keep going if you got something else here. Or worst comes to worst, come back on the next one on Friday and throw a few there. All right, because I know I've at least met the hour that I wanted to do, but I want to just get something. I want to get something else in. I want to just do a little bit. I have no idea what that is. Put that down. Okay. I want to give you a little bit of a speed challenge here. Okay.
This is definitely blue.
Because I wanted to do this. Blue. I wanted to do this game real fast. Now you haven't seen this game from when.
It's time to play a card game.
Okay. Well. Okay. Well, wait. I'm only using the cards. I'm only using the cards just because I need the numbers. Okay. For this, okay. Well, I need the number values on the cards in order to be able to make this work. Okay, here's the basics of what it involves. How many cards do I have left? Okay, so that's no, I don't want to do that. No, I'm trying to make sure I could get numbers that work here and stuff like that. Okay, we haven't played this. We haven't played this downstairs. We should try to get this on the back on the old Wii. Just do a quick little number test here or whatever. I'm gonna see how good and fast you are in this pursuit. Okay, the name. Okay, no, not like that. No, okay, no. The object. Stop it. Okay, all right. The object of
it's not funny, but you said pursuit. And
I understand. I know. Okay, all right. I want to see if you can. Okay, I'm going to give you just to kind of close this out. I'm going to give you kind of a 30-second challenge or whatever the case is, all right, before we close up shop here. All right. Now, and this is a game that you guys could very easily do with. And you know what? This is actually a good speed challenge. It doesn't matter what age you are, because I did this a whole bunch or whatever, just to keep my own skills sharp, just in terms of speed and stuff like that. I'm going to put you on the clock with this as well. I'm going to set not the calculator. I need my clock. Timer. Okay, 30 seconds.
Wait.
Reset. Okay, good.
He tried to whip me with a receipt.
Lock the door. Come on.
You promised me candy. He promised me candy, and he tries to whip me.
What are you guys getting into? What are you guys getting into? You're nuts. Anyway.
No, he promised me
so
candy.
Here's the challenge.
But then once I open the door, he starts trying to whip me with a dang receipt.
No. See, no, wait. See, you fell for the old bit from Saturday Night Live. You fell for the Candygram bit. Okay. If anybody knows out there what I'm talking about or whatever, it's the old bit from Saturday Night Live where like and they did this little quickie sketch in the wake of like everybody getting freaked out over Jaws and stuff like that. They made the
What?
joke that like Jaws had come out of the water and he was like trying to break into people's homes and try to eat them that way and stuff like that. So the bit would be, Brianna, that where it would be Jaws knocking at the door, trying to get in, stuff like that. But the person in the home would be too wise to it, and they would say, "Oh, oh no, Jaws, I'm not opening the door for you. You're gonna eat me if I open that door or whatever." And no matter how much he begged and pleaded, the person wouldn't go. But then he knocks one more time, and he goes, "Candygram," and the person falls for. It's like, "Oh, somebody sent me candy. Oh, let me go open the door." Go, it's Jaws. Ah! So that's what I mean. You fell for the Candygram bit, and Joey's 6 and he doesn't even know that. So, but that's what you fell for. You fell for Candygram. Anyway, okay, all right. Quick challenge.
Like a rain.
All right, stop. Okay, all right. Okay, all right. Quick challenge because we got to go. Okay, all right. The place I'm taking this from. This was a game that was on the Nintendo Wii a bunch of years ago. We have this game downstairs, and I would recommend to you guys, if you don't have the game I'm about to say, if you have a Wii and you don't have this game, I would definitely recommend.
This time he does have to.
I would recommend. No, not now. Try to get a used copy of this. If not, you could easily use cards like I'm about to and do the same game yourself. Okay, this was a speed math challenge exercise from a game on the Wii called Big Brain Academy. All right, and we do have it downstairs. Basically, the objective is this. Okay. Now, I'm going to do 4 cards with you on this, okay? On the lower levels, you could do this with 3 cards. So, like, if I did this with Joey, I would give him 3 instead of 4 or whatever. The object is that when I show you these cards, you got to look at the numbers on the cards, and as fast as you can, you've got to make 10. So you've got to find numbers on here that when added together, make 10. And remove those cards from the hands that I've got or whatever. Okay, so for instance, if I show you a series of 4 cards, now understand there could be 2 cards that make the 10. There could be 3 cards. You might need all 4, whatever the case happens to be. So, for example, if I showed you, Brianna,
yes.
If I showed you a 2, a 7, a 4, and a 1. Okay.
This time you actually have.
Very nice. Okay.
No.
All right. Let him see. Okay. Because I wanted to see this too. I wanted to play too. All right, but Joey, you gotta be quiet here because Brianna's gonna be on the clock. So, like for example, if I showed you these 4 numbers, Brianna, 2, 7, 4, and 1, and if I asked you, wait, no drawing right now. So if I asked you to make 10 out of these, you would take which cards from it?
7, 2, and 1.
So you would take 7, 2, and 1, make 10. Okay, I've got 5 sets of 4 cards here. Where you got to do the same thing. Okay, you gotta pull the cards that would make 10. Yeah. Okay, and I'm gonna give you 30 seconds to try to get through all 5. Okay.
God, I'm nervous.
Okay, you ready?
No.
Okay, so again, you pull there could be 2 cards, there could be 3, it could be all 4, whatever the case is. You got 30 seconds to try to grab.
Isn't there like a 10 card?
No, wait. I purposely only pulled cards 1 to 8 in this step. Okay, ready? 30 seconds. You take the cards they need. Ready? Here we go and go. Pull the cards to make 10. Yes. Okay. Next. Cards to make 10. Remember, ace is 1.
Yeet.
Yes. Next one.
I didn't know what ace was. Yeet.
Yes.
God. All of them.
No.
Yeet.
Yes. One more.
No.
Yes, and she got it with 2 seconds left. Very good. All right, well done.
I'll give her a thumbs up.
Thumbs up. Yes. Okay. and with that, I ask you guys out there, please give this video a thumbs up as well if you enjoyed the stuff that we talked about, both low and high levels, and the little challenge and stuff like that. Yeah, maybe next time, maybe at the end, maybe Joey will get a turn at the Big Brain Make 10 challenge that we just had or whatever. Okay, and we'll see what we can get in there. But in the meantime, like this video if you enjoyed it. A couple people have already, and I appreciate it. And please share this video around with anybody you think could use the help. Subscribe and tell other people to subscribe too, because hey, we had to Miss Judith who gave us several topics to do today. Thank you. I appreciate it. I hope you come by again and bring friends with you. Okay, anybody you think could use the help, tell them to come on by.
And Mr. Dice
All right.
says bye.
Yes, bye. All right. And we will see you. Okay, I should be here next on Friday at 2 p.m. Eastern time, like we said before. The only reason I say should is because I know outside of these live streams, there's a couple of things happening on the side in terms of meetings that we have to do with a few people for a few different reasons and stuff like that. And I'm keeping myself open just in case that one of them potentially runs interference with the next scheduled live stream. Okay, it's supposed to happen at Friday at 2 p.m. unless I say otherwise. Expect it to. I'm gonna set the next. I'm gonna set the next announcement here on YouTube. Okay, chill, Joe. I think I better go. Just watch the YouTube announcements, especially if you're subscribed to this channel, and you'll know when the next thing is going to happen. If it changes, you'll see it change on my front page. For now, before I get drowned out, bye. See you guys Friday.